Page 707, we are continuing section 11.7 on graphing rational functions. So we talked about previously about vertical asymptotes. Today we're going to look also about horizontal asymptotes. So horizontal asymptotes, basically what it boils down to, if you look in the concept summary box, is we have this general formula. And for this formula, there's two things we can get out of this. One is that we have a vertical asymptote at x equals b. So if it's x minus something, whatever the something they're subtracting is, we have a vertical asymptote there. And then we have a horizontal asymptote at y equals c. So again, basically like we talked about previously, the vertical asymptote, instead of necessarily memorizing this, if you don't want to do that, you could say the vertical asymptote is what would make your denominator equal to 0. We can't divide by 0, so whatever makes that denominator 0, that would be a vertical asymptote. Horizontal asymptote basically is this part is just shifting the graph. So if it's plus something, then that's increasing our y values by that amount. So that's moving our graph up that many units. If it's minus something, then it's shifting it down. And so normally, like we saw in the beginning of this lesson, we didn't talk about it a whole lot, but normally if you don't have plus a number at the end, then you have a horizontal asymptote right on the x-axis. Your horizontal asymptote is y equals 0 normally. And so if you think about that, going back to let's say we had, like yesterday, y equals 1 over x minus 3. So our vertical asymptote would be x equals 3, because that would be what would make the denominator 0. The horizontal asymptote, if you notice, there's no number being added here behind this or subtracted either way. What we could do though, you can add 0. If you add 0, that doesn't change it. And so then from that you could see your horizontal asymptote is y equals 0. One thing about vertical and horizontal asymptotes. A vertical asymptote, the graph can never cross. The graph can never cross a vertical asymptote. Horizontal asymptotes potentially can be crossed, and that'll be something you'll get into more in high school. For what we're doing, I don't know that they're going to actually cross them, but when you get into high school, you'll learn about some different functions that possibly will sometimes cross horizontal asymptotes. They will never cross vertical asymptotes though. So for problem 3, they're asking what the asymptotes of this graph are, and then they want us to graph this function. So to start with, we can look at our denominator. So vertical asymptotes would involve the denominator, and so that would be x equals 1. So x equals 1 would be our vertical asymptote. You can just abbreviate v dot a dot if you want. And then the horizontal asymptote, right off the bat, they switch things up on us. So from that concept summary box, remember it said plus c. This one is minus. So if you just add the opposite there, make it to where it is addition, and then you can see that would be y equals negative 2. Like I said, another way of thinking about it is normally if we don't have a number there at the end, if this part wasn't here, then it would just be y equals 0, and then by subtracting 2, that makes our y values all to less than what they were. So if our horizontal asymptote was y equals 0, it just shifts it down 2, makes it y equals -2. Once we have the horizontal asymptote and vertical asymptote, what we want to do is just find some points on the graph. So to find points on the graph, we want to have a few points on both sides. So I would say probably 3 points on each side would be good. The book did 7 points altogether. So here's kind of our cutoff, because our vertical asymptote was x equals 1. So these values are less than 1. So those would be to the left of that vertical asymptote. 2, 3, and 4 are greater than 1. So those would be to the right of the vertical asymptote. So right of the vertical asymptote, left of the vertical asymptote. And again, we probably could get by with just 3 numbers. So, one of these, maybe if you don't have this one, and we just have 3 to the left and 3 points to the right, that's probably enough for us to tell what the graph's going to do. We already know the asymptotes, and we already know that the lines usually, or the curved part, whatever, of this function, it's going to kind of get close to those asymptotes. And like I said, at this point, it's not going to cross either one of them. And for sure, it's never going to cross the vertical asymptote. So with that in mind, let's look at the got it number 3. And again, the starting point when you're going to do these, if you're going to be asked to graph these, the starting point is figuring out what your asymptotes are. And then from there, we can get some points and graph it. So if we look for our vertical asymptote here, vertical asymptote would be what would make the denominator 0. So basically, if x plus 3 equals 0, that's our vertical asymptote. So x equals -3 would be the vertical asymptote. Then our horizontal asymptote, if you'd like to, you can add the opposite here to make it in the same form that the book talked about. Horizontal asymptote, horizontal is a y equals, so y equals -4 would be our horizontal asymptote. So these would be the two things we need to look at when we are going to graph this. So if you wanted to, before you got going on picking your points, if you wanted to actually draw out your asymptotes, so x equals -3, that's our vertical asymptote. So you could draw a dotted line. You don't have to use a different color, I'm just doing that for emphasis to make sure everybody can see that. So that's x equals -3. Horizontal is y equals -4. So y equals -4 would be like that. So those are kind of these asymptotes, kind of these electric fences or something that the line's normally not going to cross over. So now what we want to do is just pick some x values on either side of that. And like I said, what I would do is pick 3 on each side. Picking numbers closer to it is usually going to work in your favor, where you may not have quite as big y values to deal with. So closest to -3, not counting -3, I'm just going to pick -6, -5, -4. as being to the left of that, and then to the right of that, I'm going to go with the three closest integers, which would be -2, -1, and 0. So then it's just going to be a matter of substituting these x values back in and see what y values we get. So if we put a -6 in place of x in the denominator, we'd have -6 plus 3. So that would be -3. Here a negative divided by negative would be a positive. So we'd have like 1/3 minus 4. So that would be like -3 2/3. And I'm just working these out by hand because sometimes when we're doing this, we might not be allowed to use a calculator. We might just have to work it out and get the answers that way. And I know that's not a real great point to graph, but that's just how it's going to be sometimes on these problems. We'll just estimate kind of where it goes on the graph, and it'll be good enough. So next would be if we put in a -5. I'm just going to keep going over the top of this thing. So that would give us a -2 in the denominator. So that negative divided by negative, that's the same as a positive 1/2. And then if we have a half minus 4, then that would be -3.5. So now same thing, we're going to put in, I guess I'll just cover up part of this, maybe we can get by. We put in a -4. So that would give us a -1 in the denominator. And then if we have this, -1 divided by -1 would be a +1. So that would be -3. And we can kind of look at this if you want to kind of see what's going on with those points before we do the other part. So -6, -3 2/3. We're kind of close to that line. -5, -3.5. And then -4, -3. So it's something like that. And always what's going to happen if you look at just the examples of graphs in your book, what's going to happen is it's going to be curved, and it's going to go close to those lines, close to those asymptotes, but not crossing over them. So if we look at the points on the other side, first of all, if we put in a -2, -2 plus 3 would be 1. So we've got -1 divided by 1, which is -1. And -1 plus -4 is -5. Next we can put in -1. So -1 plus 3 is 2. we've got then negative 1/2 plus negative 4. That'd be the same as negative 4.5. And then finally, if we put in a 0, that would be negative 1/3. So negative 1/3 plus negative 4 would be negative 4 1/3. So you can see what's happening here. The y values are actually getting a little bit bigger as we go here. So if we graph these, so we had negative 2, negative 5, negative 1, negative 4.5, and 0, negative 4 1/3. So it's something like that, and then we can draw the lines. Part of picking these points also is just determining which section that the graph is going to go in. Like, does it go above that horizontal asymptote or below the horizontal asymptote? So, I mean, you know, kind of you could get by with a rough sketch of it, just picking one x value on each side, and then you know like what section it needs to go in. But getting a little bit more points is probably a good idea. And if you want to pick, I picked numbers just right there. If you wanted to pick numbers a little further out, then you could do that also. Like say if we picked 6 for our x value, you know, we could get a point that's a little bit further apart and they're not quite so close bunched together. Problem 4, they are doing kind of an application of these rational functions. So problem 4, your dance club sponsors a contest at a local reception hall. Reserving a private room costs $350, and the cost will be divided equally among the people who enter the contest. Each person also pays a $30 entry fee. So first of all, it says what equation gives the total cost per person, y, of entering a contest as a function of the number of people, x, who enter the contest. So this is going to depend on how many people enter the contest because they're splitting that $350 room reservation between all the people. So the cost per person, it's the $350 divided by how many people there are that enter, and then plus the $30 entry fee. The $30 entry fee is regardless of how many people there are. So that would be an equation. And then part B, it asks what's the graph. If you'll notice with this, look at the graph that they did. And the deal is here that we know x and y both have to be positive. X is the number of people and y is the cost. So we know there has to be a positive number of people and there has to be a positive cost. So we have to be in the first quadrant. So that's why they're restricting it to that. And then if you'll notice the asymptotes, they've got kind of a different thing going here, a different scale maybe. But their horizontal asymptote is y equals 30. It's going to get close. The more people we have, it's going to get closer to just $30 a person, but it's always going to be more than that because they're splitting up that $350. Like if you can imagine if there were 350 people, that'd be a lot. But if there were 350 people that entered the contest, 350 divided by 350 is 1 plus 30, that'd be $31 per person. Okay, obviously the further away from that we get, you know, then the more it's going to cost per person. Like if there were only 5 people, 350 divided by 5 would be 70. 70 plus 30, that'd be $100. Okay, so whether we can get people to pay $100 each for this contest, I don't know, but that's where it would be at, which you can kind of see from the graph. Okay, so the idea is that we're starting out, it's a high cost per person, but then the more people that there are, they split up that $350 between them, and then it becomes less cost per person. So part C, approximately how many people must enter the contest in order for the total cost to be about $50. So if you were doing this on your calculator, you could use the trace feature where you're just tracing along the graph, or you could look at your table, and basically it works out to be about 18 people, then it's about $50. The got it for is very similar. The only difference is they're changing it to $400, and then they're asking about this, but we can do this just for practice on making sure we know how to do this on our calculators as well. So for the got it, then what we would do is we'd have almost the same thing, except for it would be $400 for the room, and it didn't say anything about a change in the entry fee, so we're going to say that's still $30. And then we could just graph that and try to see where that gets close to that point. So this, if we were to graph it, would end up something like this. And again, we're only really concerned with that first quadrant part. We're trying to figure out when it's about $50 a person. So $50, that's the Y value, $50 here, and that corresponds with about 20 people. So about 20 people at that amount of the cost, then it would be $50 a person. So if you look at the concept summary, this is basically talking about every possible different kind of function that we've talked about this whole year. So linear function is y equals mx plus b, just a plain x. And from that we can figure out the slope and the y-intercept. Absolute value function is kind of like a V shape. It kind of comes down to a point and then goes up. Square root function is kind of like a sideways half of a parabola. Quadratic function is a parabola that we talked about. Exponential function kind of curves up if it's increasing. And then rational function we just talked about is almost like two sections of that exponential function, and it's sectioned off by asymptotes. So if you look at the lesson check number 2, they're asking what the asymptotes are for this function, and then they want us to graph this. So I'm going to go ahead and look at the vertical asymptote first. So our vertical asymptote involves the denominator. Denominator can't equal 0. So if x minus 2 equals 0, that's our vertical asymptote. So that would be if x equals 2. Make sure with your asymptotes that you put like x equals or y equals and not just the number. It has to have an equation for it to be an asymptote. So x equals 2 is our vertical asymptote. So then the horizontal asymptote involves this. We have plus 3 at the end, so y equals 3 would be our horizontal asymptote. So, we could roughly just sketch something out just to get an idea of what that's doing. X equals 2 is our vertical asymptote. Y equals 3 is our horizontal asymptote. And then we could just pick, let's just say we just pick a number on each side just to get an idea of what this is doing. So if you just put x equals 0, if x equals 0, we'd have 8 over 0 minus 2 plus 3. So 0 minus 2 is negative 2. 8 divided by negative 2 is negative 4, and negative 4 plus 3 is negative 1. So we're at 0, negative 1. So 0, negative 1 is going to be over here somewhere. And so what that tells me is that the graph is going to be, just to do a rough sketch, the graph's going to be over here somehow. And then we could pick something to the right of that. So this was x equals 2. So if you want to put x equals 3, we could do that. So if x was 3, that'd be 8 over 1 plus 3. So that'd be 8 plus 3, which is 11. So we'd be at 3, 11, which just tells me that it's going to be above. It's going to be probably off the charts here somewhere, but it's going to be up there somewhere maybe. But that gives me the idea that it's in that section of the graph. And again, if doing these for real, obviously we'd want to pick more points than that, but just to quickly give you an idea of what the graph would look like, that's going to be kind of it. So if you were ever doing a problem and it was like multiple choice and they gave you different graphs, then if that's all it was is multiple choice, that's all I would probably do is pick one point to the left, one point to the right, and then that would be enough for me probably to tell which graph would match up with it. So as an application, if you look at number 3, we have this function t equals 240 divided by r plus 0.5. That models the total time t in hours it will take you to travel 240 miles at r miles per hour, assuming you stop for a half-hour break along the way. So they want us to graph it, and then they're asking what must be your average speed in order for your travel time to be about 4 hours. So we could graph this. This is, if you switch the variables up, it's like this. It's the same idea as that. So if you want to put x and y, and then you could transfer it to t and r, or r and t, I guess, if we keep the same order. Our vertical asymptote here, this would be x equals 0, or if we go with their variable instead of x, it was r, so actually r equals 0 would be a vertical asymptote, and then horizontal asymptote, and that would be like y equals 0.5, but really instead of y it was t, so t equals 0.5 would be our horizontal asymptote. And then we can graph that. So this would be kind of what our graph would look like, and I know this is hard to see from this graph. You could graph this on your graphing calculator, and it should work out to where you're looking at about 68 or 69 miles per hour. Would have to be your speed to get it to be traveling that distance in about 4 hours. And obviously there's other ways we could do that without just being dependent on the calculator. Just taking 240 divided by some number, just keep guessing numbers until 240 divided by that number plus the 0.5 until you get something close to 4. That would work also. So this gives you an idea of how to graph rational functions.